processing of student survey data. So if you have a small class, maybe whatever, however you want to define that, you might have a start of semester survey that asks, what's your preferred name? How are things going? Do you have any concerns? There's a variety of reasons for doing that. If the enrollment is small, then okay, you can review that data and decide what actions to take. I'm not listing all the options here. You might reach out to individual students, you might discuss those results with your colleagues and so on. Mail merge, if you're not familiar, combines the functionality of spreadsheets with email. So for example, if you ask students for their preferred name in that start of semester survey and their concerns, you can batch out the emails to them by saying, dear so-and-so preferred name, thank you for filling out the survey. I see you have some concerns about test anxiety or time management, and you can give a standard response, the recommended strategies for those things. That's fine, but what happens as you scale? So I teach a course with 760 students, and I don't want to not do the survey, but I'm going to miss some of the red flags and the cries for help. And so, luckily, I have a very talented undergraduate CS major who found a pipeline that is FERPA compliant, privacy policy compliant, and he can talk about what he did.
Okay, so I'll be talking more on the technical standpoint of how I did it. So the first thing when you're training any model for any purpose is you need data. And the data we had that we could train the model on was very limited, and it was really biased towards things that were like no concern. Because in a student survey, around 90% response will be something like, I don't have a problem, I don't have a problem. So when I initially tried to train the model on that, what I got was a model that said that everything was not a concern because it achieved 90% accuracy just by just saying everything was not a concern. Obviously, we can't go with that. So what I did was I used the OpenAI's API to generate training data, and I generated so I gave 5 examples from each category. Like these are 5 examples. Gave the general description and said, give me 5,000 things that have this idea in it, and that demonstrate this idea. So now I have around 25,000 really different and solid training data to train a model on. And the whole thing, and this is also FERPA compliant because I'm not exposing any real student data. I'm not training a model on student data. And this is all synthetic data generated by OpenAI's online API. And I did it for free as well. So then the next step was either I can make my own neural network or I could use a pre-existing large language model. So I used a large language model called BERT, which is specialized for categorizing data into different categories. So then I trained this model with this synthetic data, and it was able, and then I just to test it to see how it would work in the real data. I tested against the real data set of real student data real student data, and all this happened locally. Like the large language model was installed onto a device, and it was trained on a local machine. So we weren't sending student data out anywhere. So this is all really FERPA compliant as well. And then we categorized the data. So we got around 90 to 93% accuracy on most categories. And in the no concern category, which was the easiest one to identify, we got around 98 to 99% accuracy. Well, we did struggle with distinguishing between similar categories. We do think that in the future we can improve our current model to be better at this. So how do you take our finding and apply it to your class or your research? So a few of the key details that I want to discuss is our use of a large language model. So large language models are a type of foundational models, and these are basically models that companies spend billions of dollars, millions of dollars to develop, and they're really good at a general task. Like BERT is good at classifying stuff. So for most tasks, there's already an existing model. So this large language model, existing foundational model. So for whatever research you're doing, or whatever task you need, you can always just fine-tune an existing model, and this will save you a lot of time because it requires less technical effort, and it also leads to a much higher accuracy than if you were to make a model completely from scratch. So this can be used in other completely unrelated fields, such as image processing or regression. So, and then that's the thing that if you don't have enough data, you can always generate or augment existing data using the OpenAI model, using OpenAI or other similar things. Because they usually have API that you can contact directly with your code. So those are points of stuff that I think that you can apply to your own research. research as well. And then future work as to how we could generalize this to other courses other than ours. We're planning on making some sort of application where you can train your own model on your own, with your own requirements for your own course, your own categories. So this can be really generalized to the other courses as well, and not just our course. And then we're planning on upgrading this model as well, so that like we can train it with some real data, so that we can get the 93% accuracy up to like maybe 98 or 99 overall. And we're probably just like fine-tuning like how we're prompting the generation of data, just to make sure that we're doing the best way possible. So this is like a work in progress, and maybe we'll present again next year with more stuff. But yeah, this is what we have so far. Do you have any questions?
How robust is your large language model of things like misspelled words and poor grammar and things like that?
So I'm glad you asked that. That's actually one of the main advantages of a foundational model to work off on. So all of this, the basic stuff that like a human would be able to like detect, right? Things like misspellings or an unusual vocabulary, for example. These kind of things have already been trained into the foundational models. So you don't have to train all of them from scratch. All your training is to do is categorizing into what you want the categories to be. So things like misspellings, things like weird vocabulary, and with some foundational languages, foundational models, even things like a different language would also be accounted for as well.
So unless you check all of the training data, you're kind of putting AI data into a language model, right?
Yes.
Are there any concerns of like a copy kind of thing happening, where you are losing some of that precision and accuracy by using not real data to train a model?
Yes, that's definitely a valid concern, because all the data we're training our model on is purely synthetic, so there's definitely some like precision accuracy loss. But two things is, first, as you saw that there is like a pretty high overall accuracy, but again, it's not perfect, so you need like it's like a second reviewer sort of thing, where you need a second reviewer for your data. And our next step is actually ways to combat that, so that we are having more high quality data. So maybe we can give more weightage to a real data when we're training. We just don't have enough real data to train a model on. So maybe real data and synthetic data can be combined and with different weightages to get a more a better accuracy, but we're also getting like a wider variety of data as well.